Okay, fourth graders, today is Monday, October 7th, and we are getting started. We're going to continue on with Go Math this week. We did Go Math 5.1, 5.2, and 5.3 last week, and today we're going to continue on with Go Math 5.4. As you can see, our learning goal says, I can explain how factors and multiples are related. Okay, so last week we really spent a long time thinking about what are factors and how can you find the factors of a number. Okay. Today we're going to talk about how that concept is related to the idea of multiples. So on lesson 5.4 it says toy animals are sold in sets of 3, 5, 10, and 12. Okay, what that means is if I go to the store and I want to buy a package of toy animals, I could either get 3 of them, I could get 5 of them, I could get 10 of them, or I could get 12 of them. Mason wants to make a display with 3 animals in each row. Which sets could he buy if he wants to display all the animals? So, for example, if Mason goes to the store and buys 3 animals, could he put them into a row of 3 and display all of them? Could he? Yeah. Good. If he buys 5 instead, could he do that? No, because once he puts 3 out for one row, will he have some left over? Yes. How many left over will he have? 2, and that's not enough to make another row, okay? So that's what the question's asking. Let's go ahead and underline what the question's asking. Which sets could he buy? That's what the question's asking. The important information is they come in these numbers, 3, 5, 10, and 12. And he wants to make a display with 3 animals in each row. And he wants to display all of the animals. How many animals will be in each row? And when Mason displays it, how many animals will be in each row? Everyone?
3.
3. How many animals are sold in each set? Either 3, 5, 10, or 12. The product of 2 numbers is the answer, right? And as we know, the product is called a multiple. Okay, the 2 numbers that we multiply are the factors, and the product is the multiple. Factors and multiples are related. Okay, so if Mason wants to put 3 animals in each row, could he buy the pack of 3? Could he buy the pack of 5?
No.
Could he buy the pack of 10?
No.
Could he buy the pack of 12?
Yes.
Because we know that 12 is a multiple of 3. Okay, so that's why it works. One way we could figure this out is by telling whether or not 3 is a factor of each number. Is 3 a factor of 3? Yes. Is 3 a factor of 5? Is 3 a factor of 10? Is 3 a factor of 12?
Yes.
So 3 is a factor of 3 and 12. Another way to say that is 3 and 12 are multiples of 3. 3 is a factor of 3 and 12. 3 and 12 are multiples of 3. Okay. Another way we could think about this, besides finding factors, is to find multiples. We could skip count or make a list of multiples. We can say 1 times 3 is?
3.
2 times 3 is?
6.
3 times 3 is?
9.
4 times 3 is?
12.
5 times 3 is?
15.
We're skip counting by 3, or we're listing all the multiples of 3. Based on our list where the toy animals are sold in 3, 5, 10, and 12, which one of those are multiples of 3? 3 and?
12.
So, 3 and 12 are multiples of 3. So, Masons could buy sets of 3 and 12 toy animals. When you have something in common with somebody else, that means it's the same about you. Zara and Avani both wear glasses. That's something that's the same. When you have common multiples, a common multiple, there's that word common again, is a multiple of 2 or more numbers. For example, the number 6. 6 is a multiple of 2. Do you guys agree?
Yes.
Is it also a multiple of 3? Yeah, because 6 is equal to 2 times 3. So 6 is a multiple of 2, and it's a multiple of 3. We call it a common multiple because it's a multiple that 2 and 3 have that are the same. Okay? So a common multiple is a multiple of 2 or more numbers. So the question in your workbook is asking us to find some common multiples. It says Tony works every 3 days and Amanda works every 5 days. If Tony works June 3rd and Amanda works June 5th, on what days in June will they work together? Underline what the question is asking us to find. We want to know on what days in June they're going to work together. We know that Tony works every 3 days and Amanda works every 5 days. Tony is going to start work on June 3rd and Amanda is going to start work on June 5th. Let's circle the days that Tony will work. What's the first day that Tony is going to work? June, circle it. If he's working every 3 days, he's going to work June 3rd, and then June? 6. Good, and then June? 9. And then? 12. Then? 15. Then? 18. Then? 21. And then? 24. And then? 27. And then? 30. What do you notice about the days that Tony is working? 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. They are all multiples of? 3. Very good. Now, let's draw a box for all the days that Amanda is working. She's working every 5 days, and she's starting work on June 5th. So draw a box around June 5th. What's the next day Amanda would work? June? 10. Then? 15. Then? 20. Then? 25. Then? 30. What do you notice about all of Amanda's working days? They're all multiples of? 5. Good. What days did you draw a circle and a box around? 15 and? 30. What does that mean about 15 and 30? They are common multiples between what two numbers? Of what two numbers? 3 and 5. Very good. The common multiples are 15 and 30. So, Tony and Amanda will work together on June 15th and on June 30th. This is where I want to caution you. We worked last week to find common factors. Today, on this problem, we were finding common multiples. What is the difference? Turn and talk at your table groups. In our problem of the day, when Mrs. Kim wanted to place fruit, she had 12 plums, 36 oranges, and 18 apples. Do you guys remember that? We had to find the common factors. We said 12 had factor pairs of 1 times 12, 2 times 6, 3 times 4. These are the factors that make these numbers, okay? We said 36 was 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. We said 18 could be made by multiplying 1 times 18, 2 times 9, and 3 times 6. So therefore, the common factors were 1, right, 2, 3, not 4, but also 6. Okay, so those are the common factors. What if I asked you to find the common multiples of those same numbers, 12, 36, and 18? How could we find the common multiples of 12, 36, and 18? Well, we'd have to list the multiples. What are the multiples of 12? Go. 12, 24, 36. Okay, let's stop there. What are the multiples of 36? What's 1 times 36? 36. What's 2 times 36? 72. Thank you. Let's stop there. Okay, what is 1 times 18? 18. What is 2 times 18? 36. Okay, so we found the common factors up above. Now let's talk about the common multiples. What numbers are the same? 36. So 36 is a common multiple of 12, 36, and 18. So as you can see, when we find common factors, we're looking for the factors that are the same. And when we're asked to find common multiples, we're looking for the multiples that are the same.